welcome to Germinal's presentation on climate smart landscaping. And by climate smart, what we mean is, it's in a single sentence, it's choosing a process or product that is more sustainable and can help reduce our impact on the environment. So just a few short words on Germinal. So we are an award-winning plant breeder, producer and seller of grass seed into the landscape and agricultural sectors. We are a sixth-generation family-owned business which originated in Belfast, but it now has offices and teams throughout Ireland and the UK, and 3 plant breeding stations and research stations, one in Aberystwyth, one in Wiltshire, and one just outside Canterbury in New Zealand. So it's our plant breeding that we really have most pride in, take great pride in, and which we believe has given us the longevity. We came into existence 200 years ago, so it has given us that longevity, and to sustain and to be leaders in our field. And one of our core values is that we look to lead responsibly and lead ethically. And I suppose in recent years we have turned our attention to effectively what is the climate smart landscaping and products that we're looking to develop now. So in that regard, and that's why we want to talk about nitrate applications, nitrogen applications, and I suppose in the first instance, what is the problem with granular fertilizers? Well, all granular fertilizers release nitrous oxygen into the atmosphere, and as a greenhouse gas, nitrous oxide it's approximately 300 times as potent as carbon dioxide and just as long-lived. So it's really important that we, as an industry, we look at how we can minimize our use, and in the instance whereby we are using nitrogen fertilizers, that we choose the correct ones. So how can we negate that impact of fertilizer use, and in a broader sense, how can we potentially eliminate the use of fertilizers altogether? And obviously the very fact that we're posing this question kind of leads to, we believe that we have a solution and an answer with regards to eliminating nitrate fertilizers. So just to take a look at 3 potential ways that we see we can reduce fertilizer use. We can choose the likes of slow release fertilizers, and we'll talk a little bit about them in future slides. We can look at the use of organic fertilizers, and we can look at how we can create clean, free nitrogen by utilizing clover. So just to take a look at an overview of fertilizers in the first instance, and I suppose to take a look at what you might call the villain of the piece, and that being the compound granular fertilizer, the straight fertilizer. It's quick releasing, it's 100% cold water soluble, so therefore when it's applied, and it doesn't matter at what time of the year it's applied at, once it receives cold water or any kind of moisture, it begins to release the nitrogen into the soil. And even at its most efficient form, when it's applied, say, through the summer months, grass is growing strong, it still only has the potential to have an uptake of 40% by the plant, which means that there's up to 60% of the nitrogen that's either volatilized into the atmosphere as nitrous oxide, or leached into the ground in its nitrate form. It's also quite short-lived. So we suggest a 4 to week duration for compound granular fertilizers, but in actual fact, it's anywhere from 2 to 4 or 3 to 5, depending on the time of the year. So can we choose a better type of nitrogen if and when we're applying nitrogen? And in that instance, yes, we can, and that is through the use of slow release fertilizers, or controlled release fertilizers as they're known. And in that regard, it's basically applying a resin or a coating to them to try and slow down that release of nitrogen. So it is taking the standard compound fertilizer prill and coating it Originally, that would have been through a plastic coating, but more often now it's an organic or a resin coating that's placed onto it. So it's worth identifying what type of slow release fertilizer that you're specifying or applying, and to try and steer away from the older versions of the plastic coated fertilizers. We want to reduce the amount of microplastics that we're putting into the soil, and equally, those plastic coatings can remain in the sward and can get picked up and can cause more damage. So it's worth knowing the origin of that slow release element. The second type of slow release fertilizer that I just wanted to talk about is the ammonium stabilized fertilizer. So again, it's that straight compound prill that has been coated with an ammonium stabilizer. So as we know, nitrogen is taken up by the plant in the nitrate form, in the negatively charged nitrate form. It can freely move through the negatively charged soil. And by the use of an ammonium stabilizer, we are changing that into the positively charged ammonium nitrate form, NH4. As that coating is broken down, it releases it back into the nitrate form and it can be taken up. It's nitrobacteria that are breaking that down. So the rate of release is dependent upon the movement of that, or the temperature of the soils and how active those nitrobacteria are. And again, the release time frame for those is anywhere between 8 to 12 weeks. And then the last slow release fertilizer that I wanted to talk to you about today is the methylene urea or urea formaldehyde fertilizer. And again, this particular fertilizer its slow release action is created in the processing stage. So three fractions or three chains of nitrogen are created during the processing stage. You have the initial quick release portion called cold water soluble portion. So again, that is basically the straight form, but it is only a very small fraction of the overall nitrogen input there. So that will be approximately 10 to 15%. And the second fraction will be, again, the insoluble in cold water, but soluble in hot water. So again, it's releasing over a longer period of time, approximately, from week 4 to week 12. And then the final fraction from 12 weeks or approximately 12 weeks onwards, not strictly an organic element to the prill, but one that's acted on the nitrobacteria. And that particular fertilizer has an approximate duration of anywhere between 10 to 14 weeks of steady release. The other great thing about the slow release fertilizers over the compound straight fertilizer is that more of the nitrogen can be put into that prill, which gives it that longer duration of period. And the final fertilizer that we're going to talk about here today is the organic fertilizer, and arguably a slow release fertilizer in itself as well. Generally derived from plant or animal origin, blood or bone, composted plant material. This particular fertilizer is pelleted, which makes it much easier to apply to the soil or to the landscaped area. It's acted upon by microbes and bacteria in the soil. So its release period is very much dependent on the quality of the soil. But equally, as it's being used, it has that potential to improve soil structure. It also has the ability to hold moisture. So it offers a steady NPK release into the soil. I suppose the one thing to consider with regards to the organic fertilizer is that there is energy required, and there is a processing piece with to create that. And the prills can take some time to break down or disperse, again, depending on the quality of the soil. So just a very short and unashamed product plug, if you don't mind. This is our GSR, Germinal GSR triphase fertilizer, and it speaks of all the slow release aspects that I spoke about earlier on. It has that initial quick release nitrogen form in the, from week 1 to 4 upon application, the slow release from weeks 5 to 12, and then it has that organic release there from approximately 12 to 16. So it combines the trait of both slow release, which works over the 12 weeks, and the organic piece as well, that that takes the final stage, once that's broken down. Very often we're met with a concern and the issue with the cost of a straight compound fertilizer as opposed to a slow release fertilizer, and the extra cost that the slow release is. And absolutely, per bag, slow release fertilizers are far more expensive. But it's just worth considering, we've taken an area of approximately 10,000 square meters and compared both types of fertilizer in a cost analysis. And if you were to take a straight spring summer 977 fertilizer, that recommended application rate of 70 grams per square meter over 10,000 square meter area, which would be approximately the size of a football pitch, you'll be looking at 28 bags of that, at a cost price of €32 plus VAT. So an initial application of compound fertilizer is coming in at €896 plus VAT. Bear in mind that this is most likely going to have to be applied on 2 occasions through the growing season, as you're getting approximately, anywhere between 2, 4, 6 weeks worth of duration from it. So if you were to double that cost, you're looking at a cost of €1,792 per hectare, plus the associated manpower that goes with that. And having spoken with some landscapers, I would suggest you're looking at approximately €350 per application. So a total cost for a 10,000 square area with a straight compound fertilizer is coming in at around €2,500 for a season. If you compare that to our Germinal GSR triphase, which has a lower application rate of 35 grams per square meter, and as a consequence, there's only a requirement for 14 bags at a cost price of €50 plus VAT. That's an application cost of €700 plus VAT. You add in the manpower onto that of €350, that's costing approximately €1,000, €1,050 plus VAT. That GSR triphase, if applied kind of April into May, is going to take you through the duration of the growing season. And as a consequence, it's going to give you a more uniform release of nitrogen, and cost saving of approximately €1,500, which is the main important factor there. So in summary, I suppose as an industry, what we really want to be doing is I suppose reducing our fertilizer inputs, but choosing as wisely as we can. And our recommendation would be to always choose a slow release fertilizer. The spreading rate is lower, obviously, because there's a higher percentage of N in the prill. It lasts far longer as well. So less cost with regards to applications, and the associated cost with CO2 emissions through machinery. There's a financial cost saving there as well, as we just looked at, and less bags in total for a more environmentally and economically sustainable result. So what if we could potentially eliminate fertilizer use altogether, or certainly nitrate fertilizer use? And nature has one of those great synthesizers, and that is white clover. And I just want to take a very quick overview of clover in general. Obviously, we know that it has that ability to fix nitrous oxide from the atmosphere and through its root system, through nodules in its root system, and to be able to release that back into the soil to any associated plants in the area, to be taken up. The great thing about white clover as well is it has a really strong taproot, which can help improve soil structure. And the final, or the third benefit of white clover is its flower, and it is considered an essential or a recommended choice on the All-Ireland pollinator plan for bees and other pollinators. Now, I suppose you asked the question, well, why haven't we been using white clovers in our swards, for years now? And I suppose you could answer that with three reasons. I suppose compound fertilizers have always been the first choice for plant nutrition. They've been cheap, and little was known or appreciated of their environmental impact. I suppose secondly, for the best part of 200 years, public perception of an amenity grass space or lawn has been that of a fine leaf sward of monocotyledonous grasses. Though we believe that perception is changing with the recent introductions of the likes of No Mow May and the promotion of the All-Ireland Pollinator Plan. The use of wildflowers in so many of our public spaces and everywhere from roundabouts into public spaces. I think the perception of an amenity lawn as being a monospecies of monocots, I think, will change in time, to a species, multi-species rich with grasses, with legumes, and who knows how far it'll go. But certainly, that perception is changing. And the third issue with the use of clover, so up till now, has been that any clovers that have been used or any clovers that have been bred to date have not suited the landscape sward particularly. They're generally have been large leaf varieties which can dominate grasses. They're not particularly tolerant of temperature changes, either cold weather or drought tolerance. Mainly down to the stoloniferous growth, which is growing just below the surface. And that is quite susceptible to temperature changes. And they're also susceptible to damage by mowers, so they can't take close mowing. So I suppose with all of that in mind, we at Germinal thought to ourselves, well, how can we improve on all of the attributes of clover? And we believe we have, and we've introduced DoubleRoot Climate Smart Hybrid Clover. And the DoubleRoot Climate Smart is an overarching term for what will in time we hope to be a stable of clovers that we can offer to the landscape market. Everlasting is a world first. It is unique to Germinal. No other plant breeder has managed to do what we've done here. And essentially what we have done is we've taken the standard white clover, Trifolium repens, and combined it with the positive attributes of Caucasian clover, Trifolium ambiguum. Trifolium ambiguum, which is native to the mountainous regions of Africa. We have taken those two clovers. Taxonomically, it is still considered a white clover, Trifolium repens, but Everlasting has both the stoloniferous root system of standard white clover and the rhizomatis, the deeper rooting rhizomes, which go below the surface and then come back up at a later point, at a further point, and create a new plant. So it is these attributes that we believe that have enhanced clover and the ability for it to be used in the landscape setting. Just looking at in this particular slide here, we have a core sample of Everlasting, and in fairness, just straight grass, and it's really just to identify a couple of small features of Everlasting. Its deep rooting nature and its ability to help with soil structure and soil improvement. Particularly in newer landscape areas, construction sites, where it's known that soil compaction is difficult and is a problem. It has its deeper tap roots. And the other very good attribute and the great attribute of Everlasting is that smaller leaf variety, that ability to tuck in there into a sward of fine grasses and to merge in with that. So we believe that Everlasting DoubleRoot Clover has overcome the traditional weaknesses of the standard clovers. It is more drought resistant. It has greater cold temperature tolerance, and it's not as susceptible to more damage. So consequently, it persists and consistently delivers the benefits of white clover in a grass sward. So we've been asked, what kind of quantity or what kind of nitrogen fixation capabilities have clovers got, and we know that they can fix between 5 to 20 grams of nitrogen per square meter per annum. If you were to take, for example, the SGRI's recommendation for nitrogen application for a heavy use sports football pitch, their recommendations are anywhere between 150 to 200 kilos of nitrogen per year. So if you scale that back to just an amenity sward, you can really see there that the 5 to 20 grams per square meter is more than adequate to sustain a strong, healthy sward throughout the year. So how can we use DoubleRoot and how can we establish it? So in Germinal we have two mixes that we use Everlasting in. We use it in our A18 mix, which is our road verge and embankment mix, and we also use it in Aber Sustain, which we would recommend on a more general landscaping, more generalized landscaping areas. Again, like any grass seeding work, we recommend to bare soil, creating a seed bed, a friable seed bed, with a sowing rate of approximately 35 grams per square meter. The optimum time for sowing would be April through to mid-September, though we would recommend possibly at the latter end, in the autumn end of the season, simply because the clover requires good soil temperature to establish well. So by seeding in August into September time, you have that optimum soil temperature there. Paradoxically, the use of a slow release fertilizer is recommended. So just to help that establish itself within the sward. But the great thing is, once it's established, there's no requirement for nitrogen fertilizer after that point. And potentially the other way of introducing it into a sward, and we've been asked many times, can it be introduced into an existing sward? And yes, it can, and that would be through the use in the method of oversowing it, stitching it in, overseeding through an overseeding machine such as the Burrito here. Again, recommended kind of August, September time to do that. And ideally what we would suggest is that you want to try and create as a surface there, to a soil seed surface there as best as you can. So a scarification or a harrowing, a thinning out of the existing grass sward to give the clover the best opportunity to germinate and to establish itself in the sward. And any landscape provider, landscape company or landscaper, sports turf contractor will have that equipment and will have that knowledge with regards to overseeding. Again, the overseeding rate into an established sward would be 5 grams per square meter. So again, it doesn't require a huge amount to establish it into an existing sward. We are delighted that we have been able to bring to market all the benefits of a traditional white clover, and to enhance that and to make it a more user-friendly product within the landscape market and the landscape sector. And DoubleRoot Clover will remain in the sward and will remain and give the ability to supply free, clean nitrogen throughout its lifetime. So that's it. I want to thank you all very much for your time. If you have any further questions, or if you'd like to know any more, you can by all means reach out to me.